All right, year 7. Another video. This one's on solving equations with brackets. Here's an example of some of the kinds of equations that I would expect you to solve, but really, in terms of year 7, just get my pen. Where are you, pen? Draw. All right, in terms of year 7, you'd be expected to, say, solve something like this or like this, but these equations here are beyond year 7. Anyway, we're going to have a look at them anyway because you're clever cookies. Let's talk about strategy. Today in class we talked about how you could, we reminded you that the 6 is joined to the bracket by a times by multiplication operation. So I could actually reverse that by dividing both sides by 6. But we also talked about how sometimes this number will not divide into the number on the other side easily, and if that's the case, you may decide you want to expand your brackets first. So you need to actually think about which process would be better to do first. Should I expand the brackets, or should I, in this case, divide by 6 and make a smart decision rather than just expanding brackets every single time because you don't want to learn another method. So think carefully about what you should do. With these equations, expanding brackets is pretty essential. So you've got one bracket to expand here on the left-hand side and one bracket here to expand on the right-hand side. Same with this one, you've got 2 brackets, but both of them are on the left-hand side. So that means our second step will be different. We'll have like terms to collect here. Same thing again. Expand the brackets on the left-hand side, but don't forget that there's a minus here. So when I expand the brackets, that minus here will combine with this plus to make this second term a negative. So that's a big trap there. Don't forget that you'll be combining -5 with +5 through multiplication, and that will make a negative term. All right, let's do it. So, as I suggested before, 6 divides so nicely into the 18 that I would actually make my first step divide by 6. And we know that any number divided by itself will cancel to give 1 because 6 goes into 6 exactly 1 time. So then I'll be left with n minus 5. I know that there is a 1 in front, but really it's pointless writing that because 1 multiplied by anything just keeps it the same. So there really is no point writing 1 brackets n minus 5. So we've got n minus 5 and then 18 on 6 equals 3. Keep changing my colours. And then it becomes a super simple one-step equation. So we'll just add 5, and I get n equals 8. Over here, we talked about the fact that 3 can divide into 11, but it won't give you an integer. So you might decide that I'd rather expand the brackets, and it does involve more work, but probably the arithmetic's easier. So 3 times r is 3r. 3 times minus 7, don't forget it's 3 multiplied by minus 7, will give you a negative 21, and that equals 11. So this is where one of the tricks where students might make an error. The opposite of subtracting 21 is to add 21. We'll add 21 to both sides. So we get 3r equals 32. And then we can reverse the times by 3 by dividing by 3. And then we'll get r equals 32 on 3. This fraction is fully simplified, so I don't need to do anything else. I also don't have to write it as 10 2/3. 32 over 3 is perfectly fine as an answer. All right, here we're going to get some practice with expanding our brackets. I like to write in what I call a rainbow because it just keeps me aware of what needs to be multiplied. So I try to avoid any simple errors. So when we multiply 10 by m, we get 10m. 10 by minus 5, we get minus 50. 2 by m gives me 2m. And 2 by positive 7 gives me positive 14. Don't forget you must have a sign joining your terms. And now I'm going to combine or try to move this 2m over to the 10m because I like the small term to go to the big term. And this is a positive 2m. So the way that I'll reverse a positive 2m is, or adding 2m, is to subtract 2m. I'm going to subtract 2m from both sides, and then 10m minus 2m gives me 8m. I haven't touched the minus 50, so it drops down. 2m minus 2m is now 0, so I'm left with positive 14. Then I can reverse the minus 50 by adding 50. So I've got 8m on the left-hand side, minus 50 plus 50 gives me 0. 14 plus 50 is 64. And then all I have to do is reverse the times by 8 by dividing by 8. And I get m equals 8. All right, next equation has, sorry, excuse all of this, we've got to multiply the brackets again, but this time round, both brackets are on the one side. They're both on the left-hand side. So we've got 10m, 10 times minus 4 is minus 40, 2 times m is positive 2m, and 2 times 5 is positive 10. So every term must have a sign. And this is where I get to combine like terms. You will only combine like terms if the terms are on the same side, which all these terms are. They're all on the left-hand side. So now I can see that 10m plus 2m is 12m, and minus 40 plus 10 is minus 30. So don't forget to take the sign of the term with the term itself. Now I can reverse the minus 30 by adding 30. So I get 12m equals 90, and I'll reverse the times by 12 by dividing by 12, and that gives me m equals 90 on 12. Now this is an equation where I could reduce it by dividing the numerator and denominator by, maybe more than that actually, I might divide by 6, not 3. 6 goes into 90 15 times, and 6 goes into 12 2. So we get m equals 15 on 2, or 7.5, or 7.5. Any of those answers is fine. All right, lucky last. So here we have a very similar question to the last question. Oops. Sorry, I might just get rid of this. It's annoying me. Cut. All right, that's better. So get rid of that scribble. We'll put in the time signs. I think these are very important, especially when you're just starting out with all this algebra. And a reminder, I even use my highlighter here to remind myself that it's minus 5 that gets multiplied by the h and by the positive 5. These things are quite important so you avoid mistakes. So 9 times h, that's 9h. 9 times positive 5 is positive 45. Minus 5 times h is minus 5h. And minus 5 times positive 5 is minus 25. And then once again, we can collect like terms. So 9h minus 5h. Don't forget the minus over here. Very important. And then I'll use a different colour for other like terms. Positive 45, minus 25. And then we can collect. 9h minus 5h is 4h. Positive 45 minus 25 is positive 20. And I'll drop down the 64. Opposite of adding 20 is to minus 20. So I'm left with 4h equals 64 minus 20 is 44. The reverse of timesing by 4 is to divide by 4. Gives me a lovely solution of h equals 11. All right, I hope this video was clear. Feel free to watch it as many times as you need to.